Hi all, see this, in this particular problem actually we are going to first find out the equation of a plane passing through the point 1, 3, minus 7 and which is perpendicular, right, through both of the plane which are actually given as x minus 1, y minus 2 and all that. Okay, it's actually first we have to find that passing through this point and we need to drop a perpendicular from that. Okay, just reverse it. Okay. So first go ahead and see the direction of the given two line. Okay, so see that I just consider this is line 1 and line 2. Okay, so we'll say that the directions ratio of given two lines so what's that? That actually A. So A is a vector that actually 1, minus 2 and 3. B is another vector that actually the direct ratio 2, minus 1 and minus 1. So these are the direction ratio. So let C is be a vector perpendicular to both A cross B, A comma B. So that means the vector C must be equal to the cross product of A cross B. That's it. Now here we are required to find out a plane which is actually perpendicular to that. So therefore we'll say that this C, that is C is the normal vector to the plane, required plane. So that's it. That's actually our problem. Now see that we need to find out that C, right? So how we'll go and find out the C? Obviously by taking the cross product. Let's go ahead and take the cross product. So therefore the vector C, let us go ahead using the determinant approach. So therefore let us write I, J and K. Let us substitute that appropriate values here, 1, minus 2 and 3, 2, minus 1 and minus 1. That's it. Let's calculate that determinant now. So corresponding to I, we have plus 2, minus 3. So we have plus 3. Minus J, we have minus 1, plus 6. So minus 6. And let us write down the K component. So the K component is equal to minus 1, plus minus 4, so plus 4, and that's it. So therefore our C vector is became 5, 7 and 3. So this is the C vector. So now for what we are required? We required to find out a plane which is passing through the point 1, minus 1, 1 and having unit normal C. So therefore we'll say that the equation of a plane pass through one, minus 1 and minus 1 and having normal vector C. So that's actually the equation. So if I go ahead, let's write down the equation. So therefore it's 5 into x minus 1 plus 7 into y plus 1 and plus 3 into z plus 1 and that's definitely equal to 0. Let's calculate that equation. So it's 5x plus 7y plus 3z minus 5 plus 7 plus 3 and that's equal to 0. Therefore, the equation of the plane became 5x plus 7y plus 3z. This is 2, 5. So 5, that's equal to 0. So that's the equation of the plane. Okay. Now what we are looking for? We are looking for the perpendicular distance. So perpendicular distance from the point 1, 3, minus 7. So therefore we'll say that perpendicular distance from the given point, so let's write down the point, that is 1, 3 minus 7. That's equal to D. Let us write mod of 5. So 5 plus 21 minus 21 plus 5 divided by square root of 5 square plus 7 square plus 3 square. That gives you, see that, this gives you 10 divided by 83. It is 50, yeah, 83. So therefore, for this problem, obviously, you'll see that option B is the correct choice. And that's it. So it's a very simple problem. It's just applying that concept of perpendicularity and all that stuff. You can solve the same problem using that so-called vector equation. There is no such difficulties. You can also follow the vector equation and you get that answer. Here we use the Cartesian method to obtain that all the detailed solution. Okay. And that's it. Hope you understood the problem. Thank you.